Hello everyone, welcome back to Nated Engineering. Today we are doing friction, engineering science and 3. And to start the lesson, we are going to first look at the definition of friction, what friction is. So the definition of friction is a force that resists the sliding or rolling of one solid object over another. This tells us that whenever we are dealing with friction, we will be looking at two solid objects rolling or rubbing against each other. In this case, we will be looking at the ground and an object of mass m. We know the forces that will be acting on this object before any external force is being applied will be the weight, which is the product of the mass times gravitational acceleration. This object is not moving up, nor is it moving down. That tells us that this object is in equilibrium. And the one thing we know about equilibrium is that for an object to be in equilibrium, the forces going upwards must be equal to the forces going downwards. Therefore, that tells us that there is a force going up that is cancelling or balancing this force, and that force we know it's normal reaction. Normal reaction is always perpendicular to the plane that we are dealing with, always. Therefore, we're going to look at the external forces. Let's say we're applying a force in that direction. That's the applied force. We are going to experience frictional force in the opposite direction. Why? Because friction, it's a force that always opposes motion. So if we're applying a force in that direction and this block is moving in that direction, friction will be acting in the opposite direction because always friction is opposing motion. So now the normal reaction will be equals to mg because forces going upward are equal to forces going downward. And take note that this is not a standard equation for normal reaction. If we were having another force that is acting perpendicular to this surface plane, or it's acting vertical like that, let's say it's force F, we were going to say plus F because we can see that F is going in the same direction with mg. But in this scenario, since we only have these two forces that are perpendicular to the ground, normal reaction is equals to mg, which is weight. And this is also true. If this object is, if maybe you were to be asked to calculate for the minimum force that can move the block, this is the formula that we are going to use. And we know that frictional force is equals to coefficient of friction, which is mu, times normal reaction. We also have another equation that is tan theta is equals to mu. You will know about the tan theta later in the second video. But for now, we are going to continue. Let's erase this. Now I want us to look at a force, an applied force that is applied at an angle. You can see that this force is applied and is parallel to the ground. Now I want us to look at a force that is applied at an angle like that. We're going to say this is force F and it's applied at an angle of alpha. Let's erase this one. So one thing I want you to know about a force that is being applied at an angle is that it will have two components, or it will develop two components, which will be the component that is perpendicular to the ground and the component that is parallel to the ground. The reason why we are having these two components is because this force being applied at an angle, it will have two effects on the block, which will be the pulling effects that will be responsible for taking this block from point A to point B. This is having the same effect as the force that was applied like this prior to this one, the one that we were dealing with before. And this, it's a lifting force. It's a force that is trying to lift the object from the ground. So if, let's say, we were having a scale here and we apply this force, the force that we applied before, the reading on the scale will not change. But if we apply this force, the reading on the scale will change while this block is moving from point A to point B. The reason is because this force has a pulling effect, which is the component that is perpendicular to the ground. And now we have to get the values of each component. The reason why we are getting the values, we have to get the values of each component, is because we want to know how much is actually responsible for taking the block from point A to point B. Because it's not F. F is the combination of the pulling and the lifting component and the lifting force. We want to know them individually, the magnitude of each. That is why we're going to have to calculate for each. So to calculate for them, we're going to use trig ratios, which is SOHCAHTOA, we know them. So this one will be F cos theta. It's alpha, sorry, cos alpha. And this one will be F sine alpha. We're using the trig ratios to get the magnitude of each component, which will be the component that is perpendicular, also known as the vertical component, and the component that is parallel to the ground, also known as the horizontal component. The direction of the components are important when you are doing calculations. So you must learn to get the correct direction of the components. It's not that hard, but it's easy to get it wrong. So if you can't get them from this method I'm going to show you, maybe we have to try another one. If the component is like that, you can see that if we are pulling this block, mass M, it will be in that direction and it will produce a lifting effect as well. If it is in that direction, you can see it is traveling in that direction, it's a pushing, and it is also producing a force that is acting vertically downward. But if for some reason you can't do it like this, then you have to draw a Cartesian plane. Let's say you are having a force and it is in that direction. You know the components, but you can't really figure out the direction of the components. Draw a Cartesian plate. We know a Cartesian plate is something like that. So that will be your Cartesian plate. And this is the point of reference. So whenever the original force is going away, is pointing away from the point, also the vertical component and the horizontal component will be pointing away from this. But take note, you must always remember that from the Cartesian plate, if you are dealing with this quadrant, you are only allowed to use, let's say, the walls of this quadrant. Meaning, if it's away, you are only going to put it here. It's away, it's away. Don't say it's away and then say, then it's away and away. Put it here. No, because that is going to give you a wrong direction. You can see from this one, it's pointing to the right and pointing up. If you do it like this, it's pointing down and it's pointing to the left, of which is wrong. It's pointing away from the point, but you must also use the walls of the quadrant that you are dealing with. And in that manner, you can get the direction of the components very easy. So now let's look at equations. This force, you are no longer using it because from it we already got what we wanted. We got the horizontal and the vertical component. So we are going to use the components now. If you are dealing with the forces that are acting up and down, are going up and down, it will be normal reaction. It's a plus because it's going in the same direction with the vertical component. F sine alpha, it's equals to mg. We don't have any other force that it's acting vertical or it's acting perpendicular to the ground. Therefore, we are done here. And forces that are acting parallel is equals to frictional force. It's equals to F cos alpha, and we are done. This might change. If the force was acting in that direction, this was going to change because the vertical component will be pointing down. Therefore, the vertical component will be in the same direction with mg. So do not cram. Always draw this, and then from there you can have your equations. And one thing you have to remember always is that these lines are parallel and this is perpendicular. They might ask you to calculate for the component that is perpendicular to the ground and the component that is parallel to the ground. You have to know this one is perpendicular to the ground, this one is parallel to the ground. If they ask you such a question, you know which ones are components and you know which one is perpendicular, which one is parallel, then you are good. That's all we're going to do on this video. I will see you on the next lesson.